So, how many of you watched Kabali in SPI cinemas? Okay. So, how many of you watched Kabali itself or haven't watched? So, before we go into the entire topic, just I want to unmask our identities. It's actually pretty deadly to unmask ourselves because next time when you don't get tickets for all the online trolling, we will be susceptible. So, in spite of that, we will do that. So, this is a photo which is already public and pretty much used for trolls this time, which is us. Okay, the tech team. And the folks out there, Deepak from my team, from ThoughtWorks, Manita from ThoughtWorks, and Anu and Suraj from ThoughtWorks, they are also there. Apart from it, SPI team members are also present here. I will not go over the introduction. Please ensure that our privacies are maintained and we don't fall prey to trolling. So, just to give you a context around what we are speaking about, this is the stats for the Kabali day, 24 hours of the booking opening day. It's 20 million requests on that 24 hours. We had some 50 GBs of log written out, 2 million verified users, 30k users online at the exact same second when booking opened. 3 days of shows sold out in 6 minutes straight, and then 60k requests per second. So, this is the context around how Kabali looked for SPI cinemas. When you look behind the scenes, this is how it looked. Okay? And this is, by the way, twice the number of what we saw on Linga. Linga it was 10 million requests. We never anticipated any number on this range. All our estimates were taken back. That's because of. We compared it with Linga. Linga was the basis behind the estimates for how much you have to scale, but this time the scale went different. So, again, since we are going to go very deep into what are all the things we did to performance tune or change, how our servers are provisioned, I'll just give you a brief context around what are all the technologies that are being used, that are powering the SPI cinemas, right? So, obviously, we use Java and Professor as our core framework, and then Rails to support certain administrative functions, which is pretty much not exposed to any users. And then we have PostgreSQL, which is the entire DB backbone. Redis, which acts as a caching server, as well as it holds certain data. Redis holds it. Then we do use Keep Alive for maintaining which servers goes online, offline, all of those stuff. We use OpenResty. We don't use Nginx. We have replaced it with OpenResty like in the past 6 months. There is a good amount of scripts which are written in Lua which run for all the transactions. So that's also being used. We use Elasticsearch, RabbitMQ, CloudFront obviously to serve the assets and other stuff. Node.js for your all the user related operations are written. The authentication, everything is handled by Node.js. ActiveAdmin for backend administration. Ansible for deployment and Route 53 for the DNS and other support. So this is on the high level the tech stack. I'm not going to go deeper into this, just to give you a context around what are all the tools and technologies we are going through. This is on the high level. So if you look at this, I don't know whether Rajni planned on the day Linga was released for the next movie, but the performance tuning or whatever you saw in Kabali actually started from the next day when the site went down for Linga. It's literally started 1.5 years back. From there on, there are continuous changes which happen behind the scenes, multiple rounds of failures, and then we reach where we are today. So if you look at it, SPI Cinemas.in site went down, DB servers reached 100%. We had close to 2 terabytes of reads and writes on that day, and the DB server crashed with that. and then the cascading effect on app servers, the backend ticketing engine went unresponsive. So this is the state it started. Okay. Look, with that being the case, let's step back a bit and see what SPI Cinemas wanted to do. SPI Cinemas has a goal of making genuine customers feel cozy. They want to give the best environment possible, best in terms of ticketing experience or anything from there on. They want to give the best to their end users. With that context being there, the Linga went down. So both are the pictures with which we started. So this is the next thing we will obviously discuss, right? Before Kabali, this was typically one of the discussions we had. So tsunami size load is coming. What do we do? Shall we just get more servers, throw them out there, and then go over it? So it didn't look like just adding hardware at different stages will cross the game. So what we have to do is we have to completely rethink about how this entire ticketing experience itself is built in terms of the platform, how we are going to handle from there on to rebuild it slowly. It's like already the site is at full speed. People are using consistently for moving. So you need to slowly change it so that we can change the performance landscape of the entire. So that's how it was approached. So pretty much this is the idea we had. This entire slide set, what we had behind, will talk about how we are terminating the load as early as possible. So I don't know whether many users recognize it or not. 1.5 years back, we introduced the first change in this dimension, which is to introduce the frequent red and green thing. Traffic light system kind of thing came. It is the first indication given to the users to terminate as quickly as possible and send the users out. We don't want the users to stay on the site for longer. We want them to move out of the site as quickly as possible and then leave out. So this has been a consistent approach with which we have seen everything, including the redesign of the pre-book or the the process itself, how you book tickets, or the instant pay, or the fuel wallet. Everything is in line with this thought process that terminate the load as quickly as possible, move your users out, get what they want as quickly as possible, send them out. So that's consistently the overall theme behind what we do. So looking with this, the first thing obviously was to, after Linga, stabilize the backend ticketing engine as the real ticketing engine so that it doesn't go unresponsive. When it goes unresponsive, none of the users could be served. So somehow add different layers of defense to them and then make sure they are stable. The first point is obviously the multi-level throttling. When you know that a resource is scarce and it is a resource which cannot be consumed by all the users who want it, then you need to actually make sure that whoever you are sending across these multiple gates is actually the person who wanted to reach there and get it. So who doesn't want? If somebody just like that comes in and tries to see that whether the seats are available, if I have the A row only, then I will be willing to book it. All other rows I don't want to book it. If those are all the type of customers, then most probably when I don't have A rows, there is no way he is going to be served. If I send him in and I am not sending in the real users in, then it's a problem. This is one such example. It's not a direct implementation of how it goes through. But if you have rare resources across the board, we have introduced different stages so that they are throttled and only the users who have to cross the throttle will cross and move on. So implement multi-level throttling. Then semaphores to obviously handle the concurrency. So we generally reuse the connections, whatever is going through for the backend, and use semaphores to schedule it continuously. So that literally the backend ticketing engine is not free even for a second. It is given a consistent load, but at a very limited level. We don't want to send everybody in. So this is the first change which was done. And this was timed around nearly 1.5 years back during the Ajit movie. The next one is on the load on the DB. So we still have tackled only the first part, which is the unresponsiveness of the backend ticketing engine. All others still remain the same. So then the second task, once you accomplish the first one, the second task is to go over and bring in Redis cache at multiple layers so that we don't have our database being crowded. So just to give you an idea, fetching sessions on one of the peak movie days went about 1.2 terabytes of reads from the backend. So it's so much of data being read again and again, the same kind of data. So there are different stages you have to bring. The first stage is we just tripped off the reads and moved on to Redis, those reads, implementing a transparent cache. Because again, this data is very much alive data. It's not a stale data, or it's not like a data which is valid for 2 hours. When I say session or availability, its validity is minutes or even seconds for a big movie. So your data has to be fresh so that users don't get stale data. You can't book if you don't have a session at all, but you still see it in the site, then it's a problem for you. We will create users and we will create a poor experience for the user. So the data has to be refreshed literally like every minute, but the data can be cached. Its cache lifetime is 1 minute. So within that you have to build multiple layers of caching. So the first stage is to go over Redis and then move some of the rarely changing data, which is the cities, cinemas and other stuff. That's the easier part to move in. The subsequent part is frequently used data, which is the shows and availability. Availability and shows change every minute, so it was very tough in terms of moving it to a Redis like cache store, because you are going to write at the backend. The POS counters, the point of sale counters are also going to sell tickets. So you can't just cache the data here, which changes completely in the point of sale. So you need to refresh it so quickly across multiple systems. So that's what the second part. The third part is actually the transactional data. This is the next trickiest part. We have certain limitations in terms of number of active orders you can keep, how many tickets you can book with the same mobile number. There are multiple checks which are done to avoid black ticketers. So in order to do all these checks, you need to have the active orders for those customers. It's like every time a user logs in, you have to build up a cache which gets destroyed when he logs out. So that's the next stage of cache which comes in and goes out for a user in terms of the active orders and others. This first implementation of this change was done during Uttama Villan. And we saw pretty much the load for the DB was stripped off. But we don't want to give just the beautiful side of the picture. We also failed so miserably in terms of these are the two things. One is key optimization, another is single threaded. So if you are just going to put too much content into your Redis values and add too many keys into Redis, obviously since Redis is a single threaded server, you are not going to scale so much. You are only limited to the single processor, however big it can handle. So then you have to rethink about how you are actually going to put the shows or the keys. So some of the keys, for example, initially the keys were structured to be on the show level. Each show is a key. Then we have to change certain places to be on the dates, which is a group of all them. So there are these kind of minor optimization. It may look very small, but to understand and change all of these things across the system has to be done. So when you are designing Redis keys or going over that, be careful how you are putting it across. Since it's single threaded, it just takes a slippery slope. Initially it looks easy and then it takes away the entire effort. So this is this being the case, the next one is app servers still receiving significant load. Even if you have put Redis in the front, app servers are still receiving all the load. I have to rebuild again and again the showtimes pages, the movie pages, everything, and serve it to all the customers. Which is still, if you look at the 10 million requests, at least 4 to 5 million will be easily serving these kind of pages, remaining only for the seat layout and subsequent pages. So 4 to 5 million requests I have to consistently handle, which is pretty much the same information except the top bar, which has the username and the city, all of those choices, which is made by the user. So then we went in with Nginx micro caching. We just moved the caching to one more level in front. This is where we shifted from Nginx to OpenResty also. How long the cache should be valid, when it has to be cleared, all of those is determined in Lua scripts. They speak to the backend servers and change it accordingly. And then we use SSI, server side includes from Nginx, to only take the top portion. So every request you are seeing till you are entering into the seat layout is pretty much cached and served from OpenResty or Nginx, except the top bar, the login and other stuff alone goes to the app server and comes there. So the next step is also to move certain changes of the pages itself, split it into different segments and move some of the segments to CDN itself rather than even Nginx. That was because we had 150 Mbps of purchased bandwidth from Airtel, and pretty much most of the movies reached 148, 150 and all. In terms of bandwidth itself is becoming a limitation. You can't serve more customers, so we have to move some of the content out to the CDN so that we don't have to serve so much bandwidth. When you're doing caching, just be cautious. Don't read cache expiration, delete lightly. Okay? If you don't expire the cache or delete it well enough, for example, if you are implementing a cache strategy for active orders, or when the user logs in, you are going to build the cache. If you don't look at it to expire it or remove it, the problem actually manifests only during peak times. It's only all the users will try to log in during peak times. Every other moment it will run well. Suddenly during peak time, the entire response will go down. The precise reasons are cache expiration and deletion. And it's also the other way around in terms of when your number of keys increases, Redis response times also vary a lot. So just to make sure that when you are introducing these keys or the cache, the first literally nowadays when we are introducing a cache, the first task is to see what are all the touch points we are going to remove it. That is what we will do it first, and then only go on to the cache. Otherwise, we will be adding irresponsibly the cache into it. So the next one is build the cache keys cautiously. This is another embarrassing moment for us. I don't know how many of you experienced in SPI cinema some time ago. It shows somebody else's username. Okay? It's just because the cache key between Chennai and Coimbatore, we missed out the city name, the cache key. So it got overridden between these two. And it just showed random usernames. It happened we didn't realize it. All our testing, everything went fine. Because even your automation test, everything will run as one user. It shows everything is perfect. Go on, put it into production. 2 minutes down the line, the call center receives thousands of calls saying that I'm seeing somebody else's username. So just be aware of how you are defining the cache keys and how we are reusing it. The next one is don't try to force fit cache refresh times. This is something we learned because when the shows, if you look at the site, it shows only the shows which are available after now. From here on, what are the shows which are going to happen 30 minutes or 40 minutes from now on. That's what the site shows. So if that is the case, each show has a cache expiration time. Initially what we tried is, we tried to force fit everything. So whatever is the lowest one, we will clear all the cache when the lowest time went through. So that's like, every day you will clear every 5 minutes or 6 minutes once the entire cache and rebuild everything. So when each entity has its own business meaning of existence and refresh times or validity times, don't try to force fit them for entity level to come into the same dimension, because that doesn't work. When you are doing it, if each entity has a business validity time, make sure you adopt that for your cache also. So, any doubts till now? So moving on, the next one is actually till now the app was single monolithic app. It's just one Java drop wizard app. Whatever you saw, all the technologies are not existing. It's just a single Java drop wizard app speaking to Redis, Postgres. That's how it was there. Then we decided for multiple reasons we decided to split the app into multiple apps. One of the reasons from the performance perspective is to actually we don't want to each of the services we are offering or the features we are offering is not bottlenecked by the same kind of resources. For example, payment server waits for the bank to respond or something to it. So it has lots of open connections. to hold on till it gets the response and comes back. Okay, or reverse validation. The times are not guaranteed. But if you go to SMS gateway or the email gateway, it's a different problem we have. Okay, if for example, when the user has to make a choice and we are holding a tickets for him, then it's a different problem we have. So we have different problems at different stages. So that's one aspect. Apart from it, there are also maintenance related aspects, deployment related aspects, with which we decided that it's time we split that into different services. So the way it is split is users are handled as a separate service which is done through Node.js. And this is the same thing which works even from your past when you are doing wallet transactions. So it also terminates in the same website, all the transactions. So users is handled across the board through Node.js. Next is orders and the pre-book, whatever you are doing. It's all in the Java officer service, which is a separate service. And then goes to payments, notifications, and wallet. Each of them are separate services. So now it gave us to some extent the flexibility of which we want to scale. Okay. For some of the movies, we want to scale the front-end servers as well as the wallet. Or we want to scale the payment services during normal times. So the differential load can be brought in. So that could be done. So that flexibility came through. And then this again opened up a different aspect. Since we split it up, we have to introduce multiple layers of client authentication. Users try to jam through the payments when it is split across 3 services and you do redirect. People try to hack through the system without making a payment. They will try to book tickets. All of those things comes into picture. The entire state. So we have to introduce multiple layers of defense, including from your mobile app, to just cater to that part. So another is app server cache. When you just did this, what happened is when you receive 10 million requests and your server process, pretty much all the 10 million requests has to get the user. Who is the login user? To get the context around what has to be served for you. So if it tries to get 10 million, it's like for every request which is coming into my system, I'm just making one more request to the OAuth system or whatever the Node.js system we have. So we'll just route it. It creates inside traffic more than how many requests I have received from outside itself. Sometimes it creates 2 requests, 3 requests inside. So then we have to see which of the requests could be tripped off by actually adding local caches within the app servers itself. One such thing is actually the client and the user related details. So once he logs in, pretty much all the servers within SPI Cinemas builds up a cache for the user and then it destroys when the user logs out. So that's how that cache strategy was built across the board. So this is the we realized once it was going good. One day on a peak movie we realized that suddenly all the users went to order history page. And it's like everybody wanted to see the order history and we fetch every order history out there and the DB went unresponsive, app went unresponsive, everything happened. And after analyzing so much into what happened on that night, the only thing we identified is the notifications were sent late. So they were panicking that if I don't get SMS, I didn't book the ticket, let me book one more ticket and then we can cancel it through the call center. The previous one if it exists. So that triggered the mentality of all users suddenly trying to go and look at order history. So you fetch for everybody his history at the same time, 10,000 or 20,000 users, you just shift the load totally. And it was never designed for that. Order history was designed to be very few users would go there, all others will be looking at the transactions and doing it at that time. So then we realized that SMS and email sending to the users have to be so much good if you have to cater to the front end well. Otherwise, every user is trying to go to order history at the same time, and we are never going to be able to scale that. So the way we handle this, we have to again redesign the entire way about how our notifications are handled, how it is read-write, how multiple providers are read-write. Even if it's okay if we send 2 SMS to the person than not sending the SMS. So to that level, secondary resiliency was built for SMS and email. And we also introduced the RabbitMQ clustering because we couldn't go with single RabbitMQ with multiple read trace and other stuff. So this is what I said about the order history. The order history and its anxieties is a big story in itself to be researched about how users behave. So it's like sudden out of no reason in a peaceful afternoon, you will see suddenly a spike in order history. Number of users who are watching order history, which could be triggered by so many reasons. It could be because a show is cancelled or some of those information trickling out. So there are multiple reasons why users went in, and we did one thing initially. We reduced the amount of items which is shown in the order history adaptively to even 10 items. But then we had a very peculiar complaint that it's part of my life. SPI cinemas is part of my life, and the movie history which I have is so unique and personal to me. I don't want to lose it. So which threw up a different challenge of serving however big history it is for you, you still have to serve it to them. So then the obvious choice, we looked at multiple other ways of handling it. Then we decided that we do have a lot of administrative load also behind the scenes in terms of trying to see how much the users have booked it, what is the status of the ticket, all of those stuff. So then we decided to put Elasticsearch in itself as a separate platform where we will pump in different data from all the sources, and this will be used for all the administrative and maintenance loads. Plus, we will serve all the order history from Elasticsearch. So that's the next set of changes which was brought in. Again, when we did it, it's like 3 times re-implementing the indexing logic. The first time it was online indexing. For every change which happens in SPI cinemas, you open an order, you close the order, you cancel the order, whatever you do, event will be published behind, and it will be indexed into Elasticsearch. We soon realized that if the indexing process stops for a few minutes, we will be bombarding with 2.5 lakh messages or 5 lakh messages in RabbitMQ. Everything else will stop. So then the next stage is to, and also data inaccuracy. Because so much is in the queue, whatever data you are seeing behind the scenes in terms of the order history is actually not right. Then we moved on to versioning. Whatever records we are going to fetch from Elasticsearch, we will see that version. If you have a newer version in DB, we will fetch it and show it. That's the next stage we went through. That again created the same problem. Either the Elasticsearch will respond, if we are getting the response flow from that, then the DB connections will clog, or the DB in itself will clog because of other reasons. So then the next stage is to move on to job-based indexing. So now what happens is pretty much all the data is created in the databases and background job standard. They sync every second the delta to Elasticsearch, and all the queries which are running in the front end for serving the users in terms of order history or everything, we'll try to fetch the data till the last indexed time from Elasticsearch. From there on till now, whatever is available in the DB, and then overlay it and then serve it to the customers. So this is the final version of the implementation, which is now pretty much stable for last 4 or 5 months across the board. All the wallet transactions, everything we are looking at in terms of history is actually served completely from Elasticsearch. So with all this being done, just before Diwali, we were so confident that nothing will go wrong. Pretty much we have changed everything. And then the Diwali time, 2 movies released on the same time, and faced the issue where we had very peculiar error messages from Linux kernel saying no ports are available, or firewall cannot take any more requests, kernel dropping packets. So that was like, we had no clue how to handle that immediately. We just have to go back to the drawing board, rethink about exactly what has happened and go through that. Then we realized that there are different network related parameters which has to be changed, kernel related parameters which has to be tweaked, and even the disks, what you are going to put, where the log is going to be written, where the main cache content which is going to be served, all determine how Nginx responds, how quickly Nginx or OpenResty responds. So there are different changes we did for the, this is specifically for the OpenResty server, nothing else is changed. Then obviously change the U limits and other limits which are across the board, change it across the board differently. So initially it was around 30K where we failed. Then we wanted to move to 100K. That's how we started. But then we realized that even 100K might not be a right number because we didn't know. After 30K, it started dropping packets. We don't know whether it is 70K or 60K or 50K. So it might be better just we go over to 500K. Let's try to tweak the numbers and change everything in the next tunnel to the level of 500K. We even unloaded certain modules in firewall which are not filters which are not needed. Moved some of them to the front-end firewall which is outside at the network layer itself. So those changes are done to handle it. This was deployed few days before Kabali, if I am right. So pretty much the approach is the approach we followed for this performance tuning across the board is build a hypothesis. With 750 GBs of log, it is virtually impossible for any human being to understand what happened on that night in entirety and then say this is how you need to change the system. So the only way is we do guess games. The guess games start with all the trolling which happens in online. They put screenshots and say this is what happened, this is what I did, this is what. That's an easier medium to understand what happened. Take all your call center calls of complaints and then try to formulate theories. What exactly is going wrong? What could be going wrong? And then search for those hints in your log. We might still miss many of the clues which are available there. We still go through this mechanism consistently, build a hypothesis, prove it with appropriate tests. First create a test which runs the exact hypothesis in the system and proves it fails. The system fails. This cycle itself will go for some good amount of time, building the hypothesis and then proving it with the test. And then once that is identified, then fix the issue. What are the changes you are trying to? Then prove your fix with the test that it's running well. And then test functionality, release it. Again, after you reach here, you will understand that it has triggered some other problem somewhere else. You might have changed this, but it triggered a problem somewhere else. So you might have to go back to the drawing board, do the entire stuff again from the first to last. So this happens. The reason I am putting stress on that is, please don't take it after the session like there are 10 best practices. If you implement an app, it will be performant. It's 1.5 years of effort. So you have to have a very long haul in terms of optimizing and changing such systems. So if you look at the changes and how it has happened is, these are all the multi-layered caching and the data which is available. The CDN or the browser caches the images, JS, CSS, which changes very minimally. Then the web server caches the static pages with SSI. We call it static pages, but they are valid only for 1 minute. So that's static ones. So the next one is the caching server, which caches the shows, availability, everything. And the next one is in-memory cache for sessions and clients. DB for orders and pre-book. So all these layers, how to have a strategy for clearing, for building, or instantaneously refreshing it. So all of these have to be built with administrative capability. So the other point we learned through this entire exercise is we have functionalities built in to discourage miscreants. So it's also another way to stop. We don't need to solve everything technically. One such example is at 11 or 11:30 when the shows are open, suddenly SPI cinema servers will become unresponsive. Okay? The problem is, few of the users who go in just open 10 or 20 tabs. And in each of the tab, they will try to refresh, go to the seat layout. They check the seat layout, cancel it, move on to the next one, see it, cancel it. This cycle goes on because they don't get the best seats. They will look for their best seat. But if you look at it, pretty much because of some of their behavioral problems, other users started facing. So the way we changed it is we just limited it to 3 active orders, and you will receive a pop-up after when you open the 4th tab. So you have 3 active orders. Which one do you want to cancel and then proceed? So there are changes which was done in that level to just make sure the user's behavior also changes to some extent, so that we don't need to solve every problem out there. It's even you can build some features out which will solve the performance issues. So another one more thing is exactly the same thing, right? This is an example. Sorry, you have made too many requests. So this is a recently famous image which is quoted as saying the SPI servers has crashed. But actually, we don't know how to add error messages, by the way. Whatever error messages we add, there is 100 other people who will come back and say that error message doesn't do what it tries to convey. So with that being the case, you look at this error message, and pretty much the reaction is the server crashed or other things, but this was added specifically to target people who are trying to jam the system when it works through. And we blocked close to 1500 IPs when Kabali opened, which was like pretty much all of them were blocked because of its bots, or you make 200, 250 requests in a second. During Diwali, you won't believe a single user has made, from a single IP, it was made around 350,000 requests in a span of 1 hour. Okay, so that all triggered how to change it this time. Just block them as quickly as possible and move on. So next one is make small changes, test it, release it, and most probably for every 3 change, 1 change you might have to revert. There are publicly embarrassing reverts we have done. So just be prepared when you are changing such systems that you might have to revert multiple times. That's also a way to learn about how the systems work. And I don't know how many realize before Diwali as well as before Kabali, 2 or 3 days, nights continuously the site was down. It was because it was running performance tests. We couldn't create the same infrastructure in UAT or other testing environment. We just have to stop production, do this testing over the night, and then move on. So at times, if you can't create such infrastructure, even after exponentially projecting the math around how it works, how things go through, you might have to take a choice of just running it in production. So that's pretty much I have. Anything else? Any doubts?
Can you talk a little bit more about source control, continuous integration, deployment, and rollback strategies?
So yeah, on the source control, it's pretty much GitHub, which was that. Jenkins for all other purposes. Ansible is what creates the machines, deploys, and does all the other stuff. So
do you use containers?
We did try, but it pretty much went nowhere. Initially, it was like 8-9 months back, but that's not true now. It has evolved so much over the 9 months. So what we tried initially was for a very different purpose. I don't think that purpose matches. So it's a new trial we might have to do. We didn't invest so much in it. So that's on the containers bit. In terms of rollback or deployment, right? Rollback, it's still painful. No clear strategies even till date, but that's more due to the engineering efforts needed. We couldn't invest that engineering effort for some of those strategies to be implemented. But I think those are some of the areas to tackle going forward in terms of how you do rollback. The way we do some of this is as on date, whatever we have is, if it is so risky a change, just go ahead and create a new set of database tables, go over that, and even if you don't use those columns or don't use it, it still doesn't spoil functionality. It's like that we go through. And recently we have moved on to a slightly different stage where we actually move a feature into production before even anybody publicly sees it. It runs just to get, it's there hidden, nobody uses it. It runs in production, we see how the data is created. Only internal users do create some data in it, and then we will evaluate it and then take it out to public. That's another way we have slightly reduced the impact. but still no clear strategy for rollbacks. Anything else? Yeah.
When we move from India to Kabali, what was hardware scalability?
So, in terms of the app servers, we reduced two app servers. We had to provision one extra hardware, the entire VMware cluster server, just for contingencies. So, actually, in terms of the server resources, it's actually come down between Linga and Kabali. It has come down by at least 30%.
Break down your monolithic application into multiple services. So you place microservices
I wouldn't call it completely a microservices architecture, but it's services which most of the time tries to be doing one single task. But there are places where we have deviated. It's not like it does only one thing well. That's not the rule. We have broken the rule at places. That is also due to we are actually having an existing application. It's not like from the ground up you are redesigning or rewriting. So you have to move only certain portions without disrupting. So that's also the reason for. A lot. Orders changed a lot. The main orders itself changed a lot. And publicly you would realize that pre-book engine was literally changed 2 or 3 times. The UI, the entire stuff, how we collect, everything changed 2 or 3 times.
What is the major bottleneck that you have now? I would think that would be your orders database. Would that be correct? You have a strong latency system. You have to write to the data that system because that system, as you said, is already used by point of sales. You have to wait for that write to happen. The database should acknowledge that write and then send you a response. So it's not that you're not putting the write into the queue and then the database is then eventually making the change. So you have to wait for that system to write it and then. So would that be the big bottleneck for you right now?
That still remains a bottleneck, but it's if you look at Kabali, right, how it performed, I would say it reasonably performed well. We are not expecting anything bigger than this, at least for some amount of time. Yeah. For some more time. So, with that being the case, I think we'll still. I don't know whether Bahubali or others will trigger the same trend. The reason is whatever may be the case, whichever seats you get, whichever shows you get, I don't care about anything. I just want a seat. Might not be completely true for Bahubali. Slightly different user segments will create, which itself will change our load behavior. We will be safe out there. So, just those two cases.
First of all, appreciations for getting the Kabali thing and to your team and your team. So, many of the things you've done with like any reactive analytics, so you tried some experiment and it worked. In retrospect, what do you think in terms of performance tests or load tests or any mechanism that you have done to handle this fraud?
So, the first important, I would say the first important thing is initially we don't have data or feedback coming in from how the call center is actually working, what its data are, how your online trolling actually is happening, because those two are very significant sources today for us to change. In terms of business functionality, how it works, server data, everything is available. You could tune to some extent. The behavior for such large sites can trigger panic reactions. So that's something which is very different, which might have to be factored in much earlier to rethink about how we are going to. Because you might have to introduce many tripwire kind of scenarios to just safeguard your systems across the board when you are going this scale. And to some extent, this kind of scale is not even visualized internally. To some extent, in terms of the business owners, also don't visualize such scale, because I would say, right, 10 million, we projected 14 million, it came down to 20 million, which was never expected. All our maths went wrong. and up to 14 million we served well. Beyond that we slightly shook. So that's how it runs. I think taking in feeders from the other sources which are giving us in terms of how the user is going to react is more important in such systems, such large systems, than only the functionality or the technical portions of it.
So we can interpret, you said actually the cloning actually was helpful for you.
Yes, but don't do it with our names. That's the only thing. You do it, we will still learn from it, but don't do it with our names. That's the only request.
So what do you do with the logs? That was given last year. So you just store it and wrap it up to content and you do
I didn't
the
understand.
logs you generate with 750 GB. So what do you do with the logs? You analyze it, you get the messages.
So we do analyze the logs. So I would say, right, those are all based on the other information sources. We build hypothesis and then go over the logs to reaffirm that hypothesis is still existing there. Somewhere we can find clues for that log. Or else it is used for support purposes. Obviously, the customer might say, I paid for this show, but this is the show I got. Those kind of customer support still happen through those logs. But primarily, till I would say Uttama Milan also, we were able to go over the entire log pretty much and understand. Within the team, we can split across and read it. But after that, it has become very hard. And there is no way we can read some 50 GB of log now. It's just not possible. So now we are pretty much relying on other sources of problem, other indicators of problem, and then trying to find the patterns in the log.
This DB is for technology.
For the logs, logs we just split across and put it in Elasticsearch and read. Analyze it. Yeah, we did have the secondary servers, which can go online in maybe a 30-minute time.
The only reason we went to open REST is for DOS
So one of the very simple functionalities which triggered that, the functionality is we want to give all our mobile apps customizable error messages from the server. Because today I put an error message for a functionality, tomorrow I want to change that message. We want to drive it from the server. So the first strategy which came through was the services can, mobile apps can automatically ask every 6 hours or 8 hours once for that file. What are the error messages file, and they can load it and show it. That's one way to handle it. If you look at that problem, right, let's imagine that all the mobile apps, 50,000 or 100,000 which have installations of SPI cinemas, at the exact same time, if it tries to load this URL, I may not be able to serve all other URLs. So some of those were reasons we thought, okay, what else could be done? So the simplest strategy is we just have if you go here, there are multiple headers which are present here. One says about the config, another says about the message, another says about the must update, another says about the cache status, iOS config. So every response which goes out for whatever the URL, they have some of these bunch of headers which determine how your mobile apps actually work. What is the next action they have to do? We don't want to create one more request coming to our server. This is again in line with your first slide which I showed. Terminate the load as early as possible. So these are the headers which are continuously read by a mobile app and they behave differently based on these headers. There are a bunch of more headers which might go in for different pages. So to compute these changes and understand that I have to instruct this mobile app to update, this mobile app not to update, or this has to be changed, pushed to that. There are logic which you need to write. there are two choices which are available. Either move it into your app servers for every request, do some more processing and then send it back, which breaks the philosophy of moving some of the caches to the Nginx to the as early as possible stage. So then we decided we'll just implement Lua script. One of the choices we had whether to go with Nginx and the experimental JavaScript support or with OpenResty. It seemed much wiser to go with OpenResty with Lua, and it was pretty stable. From there on, there are multiple logics. One is must update, another is these kind of configs. The third is in terms of sub request caching. Multiple other things it tries to do in terms of cache purging. Multiple things it tries to do in terms of. So there is some amount of logic which resides there, which controls how the pages are rendered. Yeah. So during Linga, it was mostly availability, which was there. The shows are not moved. The active orders are not there in Redis. For the shows, actually Redis doesn't took the load even this time because we then moved on from there to the Nginx itself serving it. So it's only the availability, and this time it served for the active orders. Active orders is a significant thing in terms of the check whether the user has more than 3 orders, in this mobile number how many orders have been booked. All of those data being collected for verifying the integrity of the transactions is being retained in Redis. That's a significant amount of data which comes.
Instead of putting the error message saying that you have multiple entry login message, one of them that the current role is like this, login.
So that's this error message, right? You have made too many requests. Please wait for some time, and that's being reported as the server has crashed and it's not responding to you. So we tried all those strategies. I don't know whether we made it wrong by putting the error messages wrongly. There might be better error messages to convey it, but given the context, we started there. Statistics is pretty hard, right? Statistics is pretty hard because let me put you.
I think you need one more Redis cluster.
No. If I say we have 150 Mbps of bandwidth and 148 Mbps is used, let me tell you, right? I'm 100% sure the response from the customers is going to be like, can't SPI must buy 300 Mbps, right? So it's a reverse game. If I say when it goes down, right? If you read the comments, they will say you guys didn't scale your DB servers properly, and the DB servers are not tuned for queries. So we have zero knowledge on how it failed. We will be struggling in the dark finding where it failed with all these requests, and we do keep getting them. There are instances where people have built a kind of pages how you should render it better for performance and send it as this is how you need to build, this is the logic with which you need to build, and this is what you haven't done. So to that level we get advice, but there are only so much you could take. So we tried that, but we miserably failed that.
Guys, quick time check. I know you guys are very curious to ask more questions, but no, let's end this session with a round of applause for the team. Of course, they will be around. You can catch them and then shoot more of your questions and try to get more interesting ideas. Anyway, so we have one more talk as well, which is in a bit different form than what we have done previously. It's going to be a panel discussion. Let's take a short break and let's really keep it short. We are running out of time. So shall we be back by 7:45? Is that okay? Okay. Let's take now.
10 minutes break.
Okay, 10 minutes break. 10 minutes from now. Thank you.